It's the final countdown. Okay, good. So this is only two. We only have two more sections left. That's amazing. Okay, so 12.2 is still using the same rules from 12.1, where if you start with a 0, the integral is a c. If you start with a number, the integral is a number x plus c. If you start with an x and an exponent, the integral is this plus c. If you start with integral of number x to the number, the integral is this plus c. Okay, we get the point. So we're using all of these rules. The only thing is, we're using something called substitution, and it honestly took me about 5 calculus classes until I got to calculus 5 to remember this correctly. I don't know why, but I just couldn't get it in my head. Anyway, so when we find the integral of something janky, we use this stuff called substitution, where we pretend the janky stuff is something pretty. And then we do pretty math. And then at the end, we pull that janky back in. So let's look at part A. What looks janky about it that does not match the rules we've been using? Well, the part that looks janky to me is the parentheses, because we have not been doing some kind of parentheses to an exponent. The only thing we've done is maybe the integral of x squared or the integral of 2x. We haven't done the integral of a bunch of junk to an exponent. Yeah, okay. So on part A, the janky part is this part in parentheses, that x squared minus 19. So what we're gonna do is we're gonna take that ugly part and we're gonna pretend that it's something else, something pretty and easy. And then we'll use our math, do our rules, and then at the very beginning, at the very end, we'll pull this jank back. Okay, so let's look at our tricks. 12.2, we're still going backwards. Okay, it says how to find the, okay, first step, determine the janky part. We did, yeah. And it comes from the part that's up in here, or literally up here in the air on an E. And there's lots of other times we use substitution, but for you, these are only the two parts, only the two times. If something's in the parentheses, or if there's a letter E. And that's all of 12.2. Either you start with something in a parentheses or you start with an E. Okay, so second step, it says pretend that in here or up here, whatever, is another letter U. I don't know why we use U. I think it's because sub has a U in it. Okay, anyway, write the in here or the up here or whatever equals to U. Okay, so we're going to say this x squared minus 19 is going to be equal to a different letter, U. Just trust me. Okay, so we've done first step, second step. Third step, take the derivative of this equation. Let's go. What's the derivative of, oh, my bad, hold on, I forgot something. If you take the derivative of an x, put dx as a symbol. And then I forgot to say this. If you take the derivative, write this down on your tricks. If you take the derivative of a u, put du. And this is kind of like that last problem from 12.1. They gave us the derivative, and when they took the derivative of that d, it had that dt in it. You see it? Or the problem before that, they gave us the derivative, which involved an h, so they had dh. So whatever you're taking the derivative of, you put a d in front of it. Okay, so anyway, take the derivative. If you touch a x, put a dx. If you touch a u, you put a du. Let's go. The derivative of x squared is, circle the exponent, bring it down in front, subtract 1 from the exponent, and you get 2x to the 1. But every time you take the derivative of x, you put dx. Okay, keep going. Then it says minus 19. Well, the derivative of 19 goes away to a 0. Then it says equals. The derivative of u is, well, let's see here. What's the derivative of just a x? Is it 1? You're right. What's the derivative of just a y? Is it a 1? You're right. What's the derivative of a u? Is it 1? You're right. Yeah, okay, so the derivative of this u is just a 1. But if you take the derivative of a u, you got to put a du. All right, we're done with step 3. Step 4 says get the dx by itself. So if I want to get the dx by itself, I'm going to divide by 2x. We're going to divide by 2x, and this looks weird, but it's okay. So we have dx equals du over 2x. Okay, so what we did here was we took the dirty part, the janky part, x squared minus 19, that was in the parentheses, and we took the derivative of it. Then we got dx by itself. And you're probably wondering, what the heck is the point of this? You're about to see. Step 5, it says rewrite the original problem by replacing the janky stuff with u. Replace the dx with what you got. This is the whole point of everything we just did. Now we get to actually substitute stuff back in. So let's see here. My original problem said integral. Great. Now we're going to turn this to say integral parentheses. What did we say the inside of this parentheses was? We said it was janky, and we made it equal to the letter u. So put a u there. Keep the 14 in the air. But this dx, what did we say it was equal to? Du over 2x. And remember, in math, equals is like saying is. So this dx is going to be replaced with du over 2x. I think I wrote this problem down wrong. Okay, yeah, I wrote this problem down wrong. I'm missing something. At the very beginning of this problem, I was supposed to have a 2x in front. It doesn't change anything. It's okay. Calm down. See, like on part B, there's supposed to be a 2x in front. My bad. I didn't write it. Typo. Okay, there was supposed to be a 2x in front. I saw it, but I didn't write it. Okay, anyway, so let's go back to this hoopla. So I plugged everything in, and the reason I knew I was wrong and I got stuck is because that 2x that was at the very front, bring it down. So let's go over this again. I have the integral 2x from the very beginning, and I forgot to write it down. That's why it's not there. Okay, and then parentheses, we said that x squared minus 19 was the letter u to the 14, and then du over 2x. Okay, so we just did step 5. Woohoo! Step 6, it said things cancel. If they don't, you're wrong. This is how I knew I was wrong a minute ago, and I didn't type it correctly, or I didn't write it correctly, because now things cancel. So this divide by 2x cancels with this 2x at the front that's next to the parentheses. That means multiply. So the divide 2x and the multiply 2x cancel. They're gone. So now we just have integral u to the 14 du. Obviously didn't leave myself enough room. Okay, so we just did step 6. Now step 7 says use the rules that we just learned. Okay, well, let's use the rules we just learned. We're going to take the integral of, let's see, when we take the integral, we say, is there a number in front? And there's not. So I just go to, okay, I'm going to do u to the exponent plus 1 all over the exponent plus 1. And then, of course, there's a plus c. So this will give me u to the 15 over 15 plus c. Okay, let's see. So we just did step 7. Step 8 is to finish it by replacing all the u's with the jankiness it represented at the very beginning. So at the very beginning of the problem, we said the x squared minus 19 is the letter u. So at the very end of the problem, I'm going to say the u is that x squared minus 19. And then this is our answer. So let's go over this. First, I forgot to write something down at the beginning. I didn't see it. I don't know what happened, but it was supposed to be there. Second, I looked for the stuff in the parentheses and I named it u. Then I took the derivative and put a dx and a du. Then I got dx by itself, plugged it in, used the power rule, plugged it back in. Let's do part B. Okay, first, we're going to look for our jankiness. Our jankiness is x squared plus 4. Okay, I'll try and be cleaner. X squared plus 4. And I'm going to say that's the letter u. Then I'm going to take the derivative, where you take the exponent and you bring it down in front. And you get 2x to the 1 times dx, because every time you take the derivative of a letter, you put d and then that letter. The derivative of a 4 goes to a 0. The derivative of a u is a 1. But every time that you take the derivative of a letter, you have to put d and then that letter. So du. Okay, we just did step 1, determine the janky. Step 2, write the janky equal to u. Step 3, take the derivative. Step 4, get dx by itself. That's what we need to do. So to get dx by itself, it's multiplying by 2x. So we're going to divide. And you get dx equals du over dos x. Okay, now let's look at step 5. Rewrite the original problem with the janky u and make the dx disappear. Okay, so our original problem says integral 2x, open parentheses. What did we say this x squared plus 4 was? He was u. So I'm going to put u in this parentheses. This is a u. This is a u, okay? Then that exponent 7 stays up there. Then what did we say dx was? Dx was equal to this bad boy. So I'm going to put that bad boy just straight next to it. Du over 2x. Okay, let's see what happens. Step 5, things cankle. If they don't, you're wrong. Oh, look, the 2x being divided and the 2x being multiplied cankle. Then we use the power rule. Okay, so now we're going to actually take the integrand, or the integral. We say this is equal to u to the exponent plus 1 over the exponent plus 1. And that makes u to the 8 over 8. Then the very last step is to finish it by replacing the u's with the jankiness it represented in step 2. And then also, I'm not going to forget that plus c. Okay, so my last step is to say u. Well, what the heck was u? Here's u. And what was it equal to? X squared minus 4. Well, remember, equals means is. So u is x squared minus 4. Okay, well, let's go. So instead of u, I'm going to put x squared plus 4. Then I'm going to keep the 8 in the air, all over 8 plus c. And holy poop, you just found the antiderivative, or the integral. So if you wanted to, you could take the derivative of this, and it should cancel. Remember, if you take the derivative, you take the 8, you bring it down in front, it cancels with the 8 on bottom, you subtract 1 from the exponent to get 7. That's what we have up here. Then, because it's in parentheses, you do the chain rule. And the chain rule says you multiply by the derivative of what's inside. The derivative of this x squared is 2x, and that's why it's multiplied. Okay, let's do the next one. Part C has an E in it, but it's okay. Don't panic. Let's do our business. We're going to take the dirty part. Since we have an E, the dirty part, or the janky part, is the part that's up there. So the up there, the janky part, is 15x. So we're going to say 15x equals the letter U. Then we take the derivative. The derivative of 15x is 15. But then I have to put a dx. The derivative of u is 1, but then I have to put a du. I get dx by itself, so I divide by 15. And I get dx equals du over 15. Now we plug all this business back into the original problem. The original problem says integrand e, but let's see here. What is 15x? Well, this formula says 15x equals u. That means 15x is the letter u. So instead of 15x, I'm going to put a u in the top. And then what is d of x? Well, d of x equals, that means is, du over 15. Okay, let's take the integrand, or the integral. Okay, if we look at this sucker, it says the integral of e to the x is e to the x. And that makes sense because what's the derivative of e to the x? Still e to the x. Yeah, okay. What about, if f of x is 4e to the x, what's the derivative? Well, it's still 4e to the x. So, what about if I was going backwards to find the antiderivative? If I was given a number with e to the x and I wanted to find the antiderivative, well, it looks like it's the exact same thing. So this e rule, I can also say, okay, well, the integral of a number, e to the x, is that number, e to the x plus c. That's what we're going to use here. The only problem is, where is our number? It's in the bottom. Oh, okay, well, we're just going to kind of clean that up. Okay. Let's try and get this number that's in the bottom to look like it's in the front of the e, and then we can use this trick. Well, let's think about this. I'm about to pull this out of the air. Watch this. This e has a pretend 1 in front. And since this is all multiplied, we can say 1 over 15. What? Watch. We can say integral 1 over 15. We pulled the 1 from the e, the 15 from underneath the du. And we can do that because it's all multiplied. It's like saying 5 times 6 times 3 times 2 over 4. Because all of these are multiplied, if I wanted to, I could change this around and I could say, okay, buddy, 5/4. And then keep the times 6 times 3 times 2. You see what I'm saying? When everything's multiplied, you can take that denominator and you can put it on the last number, the first number, the middle number. It doesn't matter, as long as you take it away from the rest of them. So the point is, I have this, everything's being multiplied, and I have a denominator, 15. So what I'm going to do is take him and put him on the first number that came from that imaginary 1. And then now I have e to the u du. Okay, well, let's use this rule. Number e to the x is just number e to the x with a plus c. So number e to the, this time we have a u plus c. Okay, so we just did step 7 and we had to use a new rule. Step 8 says finish it by plugging that janky back in. So our final answer is going to be 1/15 e to the something plus c. What the heck was my u equal to? Let's see here. U is 15x, so I'm going to put 15x in the air. Whoa, okay. Okay, let's look at this part D. First, we're going to take the janky, which is what's inside the parentheses, r to the 3 plus 1, and say, hey, baby, you're going to be u now. Then we're going to take the derivative. Bring down the exponent in front, subtract 1, 3r squared. The derivative of 1 goes away to a 0. Oh, and don't forget that weird thing where when you take the derivative of a letter, you have to put d, then that letter. So times d, then that letter, equals, what's the derivative of u? Well, 1, but we're going to put d and then that letter. That shows that we took the derivative of it. Get it? D, derivative. Okay, good. Now we have to figure out what we're going to solve for. Well, if you haven't noticed, whatever is at the back of the original problem, that's what you get by itself. So that's what we're going to do here. Whatever is at the back, d of r, is what we're going to get by itself. So how do you get rid of this 3r squared? You divide. Cankle, cankle. And you get dr, Horton, equals du over 3r squared. Okay. Now, we're on step 5. Rewrite the original problem with all the janky stuff. So the original problem with all the janky stuff is now integral, parentheses. What is r third plus 1? It's u. Parentheses to the 4, then r squared, then dr is du over 3r squared. I'm just going to kind of draw a line between here so that you can see that that's okay. So now we're on step 6. Things cankle. If they don't, you're wrong. Oh, look, our squareds cankle. Yay. Now we're going to use that trick that we just did on part C, where we search for my good friend Juan at the very beginning of the problem, and then I throw him on top of that denominator that's left. So if I look at this sucker, I have a pretend 1 at the very beginning of the problem. So I'm going to take this 1 and put him over this 3, like we did on the last example. So this is going to become integral 1 over 3 u to the 4 du. All right, now we use our integral tricks. Okay, when my integral trick says, oh no, there's a number sitting in front, so I'm going to put that number sitting in front. Then I'm going to put u to the exponent plus 1 over the exponent plus 1. Then let's do the math. We get 1/3 u to the 5 over 5. Then we're going to divide these in our calculator like we were doing in 12.1. And I'm going to put parentheses around the 1/3 because I'm paranoid. Parentheses, paranoid. Press math, enter, enter. And I get 1 over 15. What? This trickery. What? Okay, so we get 1 over 15. And I'm running out of